Hello everyone, welcome back to another math concept video. So today we're going to be continuing our journey in algebra. So today we're going to be doing 1.2, graphs of equations in two variables and B, circles. Now, for part A, graphs of equations in two variables, the definition usually is, express a relation between two quantities. Now, when it comes to, in other words, the points you're plugging in the graph must align to the function given, if any. So I know that the book gives you like normally this type of definition no matter what. We as students have to kind of figure out what that means. So for example, I'm gonna give you guys an example on the next page, just to see how we're able to put this in math problems. So for example, for the first one, we have y equals x squared plus 1. So we're trying to figure out if this is an equation in two variables. And how we do that is that we plug in points, if we're given any, to this equation. And we have to figure out if it applies to it or not. So here, I'm going to give you guys 4 different points that I'm going to label here, A, B, C, and D. We have the point 310. We have point 13. We have point 103. And we also have the point 25. So our job is to figure out if these points correspond to our equation. So what we do, we just plug in for each variable. So here, we know that y in this case would be 10 equals, 3 squared plus 1. In other words, it would be 10 equals 9 plus 1, which does equal 10. So this one does apply, because when you plug in that into the equation, it does give you the right y. Now, let's try the next point, B, point 1 and 3. We have y as 3 equals 1 squared plus 1. So it's 3 equals 1 plus 1, which is 2. Now this is not the same as this, so we know that this does not correspond to the function. So of course, B doesn't count. What about C? We know that our y is 3, and we know that our x is 10. So 10 squared plus 1, that's 100 plus 1 equals 3, which is 101. Now this, again, it's not the same as this. So of course, C doesn't work either. Now for the last one, 5 is y, and then we have 2 squared plus 1, which is 5 equals 4 plus 1, which is 5. So this does correspond to the equation. So we also know that that one also works. So the ones that only work for this type of problem are the points A and D. In other words, those imply that those are the definition of two variables, which is what the definition kind of comes down to. So now that we know that, we're gonna be talking about now what makes intercepts in a graph. Meaning, when we have these type of two variables, you're usually gonna have some intercepts, and usually those intercepts correspond between the x and y intercepts. So now I'm gonna kind of give you guys a definition and kind of ways for you to figure out if it has one or the other or both. So usually when we're talking about the x coordinates, we usually talk about the x-axis, and when we talk about the y coordinates, we talk about the y-axis. And usually when we're trying to figure out if it has an x-axis or a y-axis intercept, we have different ways to set up those type of information. So here I'm gonna label this 1 and 2. So for the first one, in order for you to figure out if it has an x-axis, we obtain that by setting y equals 0. Now this information, it might not be a lot now, but once we start doing an example, you'll see why I said y equals 0. Now for the second one, for you to figure out if it has a y-intercept, we usually obtain that by setting x equals 0. So usually the other variable. And when it comes to graphing these two type of intercepts, what I mean by that, usually when we're talking about the x-axis, here I'll label that number 1 for the graph. Let's say that we have this type of graph, right? So right here, let's say that it doesn't really matter what the graph is as long as it's like this. If it crosses the x-axis or the horizontal line, you know how on the previous videos we were talking about that? So if it does touch that, we know that that contains the x-axis intercepts. Now, when we talk about the y-intercepts, which I'll show up here, I'm gonna just do a graph real quick. So let's say we have a graph looking, I don't know, like this, right? So usually now any point that crosses the y-axis, in other words, your vertical line, these points, we know that it has a y-axis intercept. So of course, there's a big difference between the x and y intercept, but in terms of an image, this is how it will look like depending on which one you're trying to figure out for the type of problem you have, right? So now, let me give you an example for this information. So for example 1, right? Let's say we have, or I'm asking you, find the x and y intercepts for the function y equals x squared minus 2. So that's our function, right? And we're trying to figure out the x and y intercepts. So going back to what we did in the information here, so 1 and 2, we put that information. So for the x-intercept, in order for us to find that, we have to set y equal to 0, right? Because that was the information we got here. So what we do is for any y you see in the function, we set it equal to 0. So it'd be 0 equals x squared minus 2. And then we figure out the x-intercept by solving for x. So of course, we take the 2 to the left-hand side, so we have 2 equals x squared. And then after that, we want x by itself, meaning we want the leading degree to be 1. Here, the leading degree in x is 2. So how we do that is we take the square root to both sides. And when you do that, keep in mind that the other variable is going to have a plus or minus. So in other words, you're going to have x equals plus or minus radical 2. In other words, you already found your two x-intercepts, which is x equals positive radical 2 and x equals negative radical 2. Now, when it comes to your y-intercepts, we said that we are setting x equal to 0. So for any x you see in your function, you're setting it equal to 0. So now we have y equals 0 squared minus 2, which we're solving for y now. And in this case, your y is negative 2. So for this one, we only have one y. But for the x, we have two solutions. Now, if you want to put them in terms of points, this is how it will look like. For this one, it will just be 0 and negative 2 for the y-intercept. And then for the x, it would just be radical 2, 0, and also negative radical 2, 0. So this is what it means in terms of a point and finding your x and y-intercept, right? Now, for the following topic, well, what if, usually this example, you won't see it till later, but I think it's always a good idea to try to figure out. Well, what if you have something, something more concrete, something more to figure out? Let's say we have y equals x cubed plus 3x squared minus x minus 3, right? So pretty much what we did earlier, it wouldn't really much apply to this one just because the leading degree now is 3. And what I mean by leading degree, look at your exponents of each variable and look at what the highest degree is for that function. For this function, it would just be 3 because that's the leading degree. Now, for this one, it'd just be harder for us to try to figure out. But in terms of like trying to solve for it, finding your x and y intercepts, because that's what we're looking for. Finding x and y intercepts. And the way we figure those out is that, again, x-intercepts, you would set the y equal to 0. And then your y-intercept would be setting x equals 0. So it's kind of the opposite to trying to figure it out. So for the x-intercept, we're setting it y equal to 0, right? So let's do that. But first, we got to try to condense this even more for us to figure it out. So we're going to use something called grouping. And I'm not too sure if you guys have seen that before. But we'll do that more later on in the courses and the videos. So just keep that in mind. So we're going to have y equals x squared, or x cubed, sorry, plus 3x squared minus x minus 3. So what I usually do is you pair the first two together and you pair the second ones together. So what you're going to end up having to look like, it'll be x cubed plus 3x squared, brackets, let's put a minus 1 bracket, x plus 3. And the reason why I put that is because we want to have it condensed in terms of like how this will want to be the same as the other one. Because when it comes to grouping, we always want to have inside the bracket the same. So then that way they could combine like terms, meaning have them together. So in other words, what I did here, I kind of put them together, are the same, similar. So then that way you're able to kind of put them all together. So for the first one, what I did here, I just factored that x x squared out of both variables. And then for the other one, I just took out that -1 in order for it to look like that. So now we're able to have y equals x squared minus 1 and also x plus 3. Here, let me write that x plus 3 better, so that way it could look better. And now we solve for the x by setting it equal to 0. So it's 0 equals x squared minus 1, x plus 3. So I'm gonna go to the next page so we can solve for that. So for the x-intercept, we said that it's 0 equals x squared minus 1 and x plus 3, right? I think that's what we said. Yeah. So it would be 0 equals x squared minus 1 and also 0 equals x plus 3 since they're both, different. So for the first one, we add the 1 to the left-hand side. So we have this. And then, of course, you take the square root. So you're going to have the square root of 1, which is just 1. So it'd be plus or minus 1 equals x, right? For the x. For one of them. And then the other one, you subtract the 3 to the left-hand side. So we have -3 equals x. So at this point, we're going to end up having 3 intercepts. Either x, -1, x plus 1, and also x equals -3, right? And then when it comes to the y-intercept, what we're doing there is that we're setting x equal to 0. So for every x you see in your function, you're putting it at 0. In other words, it'd be y equals, well, this is the equation we started off with. So for every x, it's 0. So it's y equals 0 squared minus 1, 0 plus 3. So y equals -1 times 3. So the only y variable we have here is -3. So the points in general for your x and y intercept, we have 0 and -3 for one of them, which is this one. -3 and 0 for your x. -1 and 0. And 1 and 0. So those are your x and y intercept for this problem. Now, on the other section, this would be the end of the first part of 1.2. The rest, we're going to be talking about circles, which is the other section, and also symmetry. So it's just another part of 1.2, which we're going to cover on the next video, okay? So I hope this was more informative when it comes to 1.2, definition in two variables. And then on the next section, we'll talk about, the next part of the section, we'll talk about circles. Alrighty, thank you very much for tuning in and watching. I hope you enjoyed it. Alright, peace out.